Hello, I'm Neeraj. Today I will try to explain a very important concept like how Transformer supports autoregressive language models. These days, large language models like GPT and other language models are using the autoregressive language models. And at the architecture side, they use Transformer decoder architecture for this. So, in a step-by-step manner, first we will try to understand in a very simple way what is autoregressive language model, and then we will see that how transformer decoder architecture supports this. So let us start. Suppose we have a very simple sentence like the cat sat on the mat. Now we divide the sentence into tokens. So the tokens will be like 6 tokens, like the cat sat on the mat. So 61 to T6 we are representing it. So we have now 6 tokens. The main task of autoregressive language model is next token predictions. Means it will predict the token I plus 1 by considering the token T1 to Ti. So in this case, suppose we have tokens like the and cat. So this is token T1 and token T2. Now the task is to predict the token T3. For that, the system actually checks from the vocabulary. Actually, what happens when we train the large language models, we prepare the vocabulary of words. So then it will try to identify the vocabulary through some algorithms. So suppose vocabulary words like sleep, eat, sat, they got. And now the task is to calculate the conditional probability of T3 given T1 and T2. So suppose we got the conditional probability like 0.08, here we got 0.02, and here we got 0.8. Suppose the other words are also there. So in that case, we see that this is getting the highest score. So the system will extend the sequence by adding the another context, the cat set. So now our sequence are T1, T2, T3 contains 3 tokens. Now the task will be to calculate the 4th token. So again we will check with the vocabulary. Suppose the words are like on, in, to, into. Based on that, the system will, based on the conditional probability, the system will predict the next token. Suppose this is 0.85. So this will be as a next token. So it is clear that how autoregressive language models are actually working. So this is an iterative way. So incrementally it will increase the sequence length, and it will go generate the longer sequences. In mathematical way, we can represent the autoregressive language models like probability of token T1 to Tn equal to probability of token T1 into conditional probability of token T2 given T1, conditional probability of token T3 given T1 T2 till conditional probability of token Tn given T1 to Tn minus 1. So this is the mathematical representation. Now, how transformer decoder architecture actually helps in achieving this or kind of autoregressive language models, because all large language models, the core part of large language model, core trained language model is actually just next token prediction. This is for a lot of LLMs, and on the top of this they generate a lot of applications. So this is the architecture. Now how transformer decoder architecture helps. In the transformer decoder architecture, we use self-attention in a masked way. So how masking helps? So masking helps, suppose you have a scenario like you are preparing for exam and you didn't see the question papers beforehand. So in that case, you will prepare well for your exam and you will learn a lot, and you can do good in examination also. So just think on a similar direction. So how the masking is working. in a masking, suppose we have masked architecture that is represented as a matrix here from T1 to T6. So you can see that if we are at token T1, then we can see this token. But suppose we are at token T2, we can see the previous token and the current token. But we cannot see the other tokens after that. Similarly, if we are at token T3, we can see the previous tokens, but we cannot see the tokens after that. And we can see the token T3 itself. So here you can see in the system. So when we are at token T2, we can see T1 and T2. When we are at T3, we can see T1, T2 and T3 like that. So how it helps? That is clear because it helps in getting the context in a better way and it avoids the leakage of information which can affect the quality of training. Now the next part is feed forward network. So after masked attention, we use the feed forward network. So what is the use of feed forward network? Mostly here people use different combinations. Some people use linear layer, some people use linear layer plus ReLU layer, then again linear layer. So such kind of combinations are used. The main aim of this feed forward network is to improve or refine the contextual informations that we are getting through self-attentions like this. And after that there is an autoregressive process. So autoregressive process is nothing just like this, like predicting T3 given T1, T2. So such kind of process. This process we achieve through softmax. So let us go into the more detail. Let us try to go into more depth. So suppose we have to predict the token T6 through autoregressive language model process and we know till token T5. We don't know this part. This is not included in the text. And we have this information only. We have to predict this. So how the entire system will work? So the first part will be like embedding. We can do the embedding for each tokens and then we can do the positional encoding also. That is clear. And after that we apply the math multiplication. So for calculating the token T6, what we have to calculate conditional probability of token 6 given T1, T2, T3, T4 and T5. So this we have to calculate. Now here the masked attention model will help you in getting this context in a more better way because we are not able to see T6 till here. We will see T6 at this point, not at this point and at this point. So till this point we will improve the context only because here it is masked, 6 is masked. So in that case, what kind of informations we will collect? Probability of T1, probability of T2 given T1, probability of T3 given T1, T2, probability of T4 given T1, T2, T3 and probability of T4 given T1, T2, T5, T3 and T4. So suppose we are here. Now this will work like a query. We are here and we are calculating the context with respect to T5 by using the self-attention layer in a masked way. So this will be equivalent to this. So in this case, here our query will be T5. And what will be our key? Because we can see this also, this also, this also, this also, and this also. So our key will be K1, K2, K3, K4 and K5. Similarly, our values will be D1, D2, D3, D4 and D5 because we can see till D5. So in this case, first part is math multiplications, that is a dot product. So our dot product will be this. So we will do this part of operations here. So in that case, it will be like Q T5 and transpose of K. So it will be dot product K1 to K5. So this way we will calculate the dot product. This will give like how how similar or semantically important or close T5 is with respect to all these words in this context word. So this way it will calculate. The next part is to scale it. So to scale it, we will divide it as a root dk, which is actually the size of key. So size of key is 5. So we will divide it by root 5. And after that, we have to take the softmax score. So softmax score actually sharp means give the sharp edges of the contextual importance of this word in this context. So this kind of sharp information they will give. Now suppose we have some initial random value that is randomly initialized here. You can see my previous video lectures to see how we randomly initialize such values. So key, query and the value. So suppose we have the value and then we will multiply it, take the dot product with value. After some iterations, we can get the optimal values for V also. And this math multiplications means this complete part will give the context vector, and this will nearly represent this part. So similarly, we will have all such informations before going to predict T6. So now the next part of this is to get the feed forward network. So feed forward network will contains linear layer and ReLU type of layers. This will refine this context vector scores. And after that, we apply the autoregressive process. Autoregressive process is actually same kind of things that we applied earlier. For example, suppose we say that the and cat, and we have candidates like eat, sleep, sat. So maybe thousands, 2,000 such kind of candidates are possible. So based on that, what kind of output we are getting, it will come here, and weight matrices and bias, that is actually learnable parameters. And after that, we will get the softmax score, which will decide that after learning, after a lot of iterations, which may be the best suitable word as a next token for this context. And here in this case, which will be the next best T6 value. So in this case, what will be our calculation? Probability of T6 with this. So for example, we have the cat set on the. So the cat set on the. So what will be the next best value, best output? That will be calculated here, and with respect to some weight matrix, which is a learnable weight matrix, and the bias B we are using, this is also learnable. We will calculate the softmax score, and based on that softmax score, we will be able to decide that if the contextual means background context is the cat set on the next token will be met. Similarly, we can repeat the process to increase the token length. So this is the process used in the autoregressive language models to train the autoregressive language models. So I feel that you will be able to understand the background, and I hope such kind of informations will help you to think and do something better in these directions, or to improve such kind of models. So I hope you enjoyed this tutorial. So thanks for watching.